Hello friends, while taking class today morning, that is 18th of April 2020, it was very unfortunate that a lot of you were unable to define different types of relation. Due to that, again I am making one video and I will explain what is relation, different types of relation, equivalence relation and equivalence class. So first, what is relation? Simply, if there is non-empty set A, relation is subset of A order A. If there are two sets, A and B, then if relation is from set A to set B, then relation is subset of A order B. Generally in our class, this plus 2, will be associated with relation from set A to set A. Okay. So what is relation? If there is non-empty set A order A will be formed, and you can form A order A, and relation is subset of A order B. If relation is, there are two sets A and B, and relation is from A to B, then relation is your subset of A order B. It's a very basic and simple definition. Now next is different types of relation. We start with null relation or empty relation. If relation is from set A to set A, that is also called relation on set A, and phi belongs to relation, then it is called null relation or empty relation. Do remember, phi is also subset of A order A. Number second, universal relation. If relation is from set A to set A, and every set is subset of itself, and if A order A is subset of A order A, then it is called universal relation. Then it is called universal relation. We can give an example also. Suppose a set A contains 1, 2, 3, and relation definition is x comma y such that mod of x minus y is greater than equal to 0. Then when you form different order pairs, always difference of two number and their modulus will be greater than equal to 0. So each and every ordered pair, how many ordered pair will be formed? Total ordered pair will be 9. If here all 9 ordered pairs are in your relation, and that is called universal relation. So simply, if you are making relation from A to A and A order A is subset of A order A, then it is your universal relation. Then identity relation. A relation R on set A is in identity relation for each and every A belongs to set A if A comma A belongs to relation. Okay, and you can write here only also. Why only? When I define next type of relation, tab pata chalega. Means, for example, if set A is there, 1, 2, 3, then A order A. That means for identity, usually we write it as I capital IA. If it is 1, 1, 2, 2, 3, 3, then it is identity relation. Only 1, 1, 2, 2, 3, comma. Now, next is reflexive relation. A relation R on set A is reflexive for all each and every A belongs to set A comma A belongs to relation. That means if set A is 1, 2, 3, then for reflexive you must have 1, 1, 2, 2, 3, 3. Now the question is, what is difference between reflexive and identity? So do remember, all identities are reflexive, but all reflexives are not identity. This is reflexive. Reflexive can be also like this also. 1, 1, 2, 2, 3, 3, and 1 comma 2 can be also. Okay, so this one is, you can say it is your identity as well as reflexive, but this is only reflexive. So तभी while explaining identity मैंने उसके definition में क्या लिखवाया था, only, और इसमें ये तो रहना ही मस्ट है 1, 1, 2, 2, 3, 3, और इसके साथ भी कुछ और ऑर्डर पेयर हो सकते. नेक्स्ट इज symmetric relation. A relation R on set A is said to be symmetric for all A comma B belongs to set A if A comma B belongs to relation. This implies that B comma A must also belong to relation. It's very simple. If line 1 is parallel to line 2, this implies that line 2 is parallel to line 1. Example number 2. Ram and Shyam lives in same locality. This implies that Shyam and Ram lives in same locality. So this is your symmetry. Do remember symmetric में अगर 2, 3 दिया हुआ है तो आपने क्या सर्च करना है 3, 2. अगर नहीं दिया not given so no problem. Okay, and do remember your empty set, that is your phi, is also example of symmetric relation. The next one is transitive relation. A relation R on set A is said to be transitive for each and every A, B, C belongs to set A if A comma B and B comma C belongs to relation. This implies that A comma C belongs to relation. If A comma B and B comma C belongs to relation, this implies that A comma C belongs to relation. Line 1 is parallel to line 2 and line 2 is parallel to line 3. This implies that line 1 is parallel to line 3. So this is your example of transitive relation. Now, if any relation is reflexive, symmetric, and transitive, then it is called equivalence relation. तो क्या बोलते हैं equivalence relation. तीनों में से कोई एक भी नहीं होगा then relation is not equivalence. Then comes last one is equivalence class. Equivalence class की बात तभी आती है जब relation equivalence relation. Okay, so what is equivalence class? A equivalence relation on set A. Equivalence relation, पहले equivalence class की बात तभी आती है जब relation क्या equivalence है. So what I am writing, equivalence relation on set A is having its equivalence class for each and every A belongs to set A. The equivalence class of A is set of all elements of A. Set of all elements of A which are related to A under relation R. So this is the definition. Equivalence relation on set A is having its equivalence class for each and every A belongs to set A. A का equivalence class is represented as this. For each and every A belongs to set A, the equivalence class of A is set of all elements. It's a set. It is a set of elements of A which are related to A under relation R. Mathematically we can write equivalence class of A is defined as for X belongs to set A such that x comma A belongs to relation. And do remember that when equivalence class is there, when equivalence relation is there, so it divides the set into partitions. And if you do union of all the partitions, it will be the set only. So this is only, these are the terms and these are the types of relation in chapter relation. Thank you.